Well, I'm back, guys. I think we're gonna call this the Atwater Kent or AK-67C Part 1. I was going to work with the RCA radio, but I had this up on the bench, and I thought, showing it to you guys, and I thought, well, I'd kind of do some checking and stuff. That's when I found out about had problems with audio transformers. There's actually two of them. It was in a box. Sets over here. Well, let's see here. I'll show you on the schematic. This one is got an open secondary. The primary's alright. And then this one is completely open. Primary, secondary is completely dead. Open. Not so concerned about this one, as I can do a resistor capacitor coupling here and just get rid of the transformer. I'll just put that inside the box. It's real simple to do. Put about a 20 to 100K depending on what we'll end up with for plate voltage here. I have to figure that up yet. Resistor 0.1, probably somewhere around 0.047 to 0.1 capacitor, and then like a 1 mega ohm resistor coming off the grid. Now this one here is a little different. This is the one that I either need to do something with, come with something for that, because it's the phase inversion. Now if it just was the primary out, I'd put a plate resistor in and a capacitor coupling to here and keep the secondary, but both sides are out. Now what took them out, and I don't know if you can see it, but there's corrosion in here. When I pulled open started opening it up a little bit, this is the center tap connection. It literally just completely fell loose. The wires had corroded off. As you can also see, the rust on the core. So even though they're potted really good in a tar wax type substance, whatever moisture was in there when they were first potted ends up corroding them and takes them out. Now I know how many windings is in this. Now there's a trick doing that. Basically what I did was I looked up, I sized the wire, and there's no way I'm going to show it on the camera, but there's a little piece of the wire there. It's gauge number 44. It's what they call a 2 mil wire, which is a 2/1000 diameter wire. I looked that wire up in a design handbook, which gives me resistance per foot. Figured that up. I knew how much resistance is supposed to be from someone had originally done the resistance readings on good ones. So they're around about 7,000 ohms. From there you can tell how much footage is in there. When you really kind of look close at the coil, you can kind of generally get a pretty good idea of the dimension across here. And once you got that, then that'll tell you how many wires it takes to get across there by knowing the thickness of the wire. And then from this point here to this point is the two end points of it. So all you got to do is either count them or measure this distance and figure up by thickness of the paper along with the wire how many windings can be around here. And it works out about 6,000 windings. It'll be, the actual number be give or take a couple hundred, but it'll be somewhere around that. But without tearing it further apart, I don't know what the primary wire size is. It could be totally different size, and most likely is. So I don't know exactly. My guess is it's probably pretty close to 1-to-1, because it's really an inner stage, and its primary job, more or less, besides coupling, is to phase invert for the push-pull. So generally they weren't that concerned about a step up or anything in these at that point. Now from there, there is some minor rust issues, like right around here on the chassis here where the capacitor bank had set, as well as on the steel plate that bolts down to this, but they're pretty darn minor. In fact, that's the worst there is. The rest of it's just really simple stuff, and then of course the other part I still got to clean it. It's just simple cleaning, so it's going to come out really nice. I have already started dismantling the sardine cans and getting some of the capacitors out. I got one more to do. If you ever wondered what they look like, that's what they appear like. That sits inside these cans. And then the other thing too is there's 3 of these resistors in there, and they're all out of tolerance. So what I'm thinking about doing is molding this part only, so that, or making a mold of this, and then I can put a resistor in there and mold up one, paint it, and then put the ends back on. But if you ever wondered what was inside one, if you can see it, maybe if I can come down here, it's like a piece of lead pencil, and that's all it is. And it goes through a small hole, which is probably not going to be seen too good. That's in these. Now some of these will have multiple holes, and they may or may not have the graphite in them, but only a few of the holes is filled. But those are called, their actual name is tubular ceramic resistors. Now this is the field winding of the speaker. I got the speaker tore apart because when I was checking it, I found a problem with the voice coil. Minor, very minor. It's actually extremely minor. If I can show it, there's a break just in the lead wire. Voice coil is good, in real good shape. These come out real easy. They just unbolt. You take out the outside screws. There's 3 plates that help hold it and support it. Then you got a center screw, and that keeps it centered on the spider and keeps the spider centered, and they just lift out. So I'll fix that. There is one other little thing. I didn't have to take the basket off, but the basket does have a slight bend in it. I think I got it down here. So if you look down the edge there, you'll see the bend, and you can see right in there where there's some paint loss here. So this thing has been dropped, so I gotta take and straighten it out, and then I'll put it back together and fix that wire, and the speaker will be good to go. Now someone asked about the voltage on these batteries, so I went ahead and hooked them up. Across these 2 leads here should be the maximum voltage across all the cells, and that's 22.5 volts, or negative 22.5, but I got it set up so it's positive. As you can see, and it's dropping. It's 3.2 and dropping quickly. And the other one doesn't test much better, about a volt higher. The rest of the voltage readings are just as off. I think this one, like the 16 volts on this one's reading, I don't know, about 2 or 3 volts and so forth. So they're just nice to look at. When I rig up, I've got a battery eliminator style power supply. I think it's Atwater Kent. It has no model number or brand name anywhere I can find on it. It was a set alone that would have set beside the radio or something, and it had the speaker and everything in it, plus the C or the A transformer, as well as the other voltages needed for the entire radio. And I've got to it's going to have to be rebuilt, and restored all by itself. So it's going to take me a little time between getting this thing all cleaned up and everything ready for it, get the capacitors all stuffed, resistors taken care of, and then getting it reassembled. The power switch, I'm probably going to have to either, if I can't find something to use for it, which I might be able to with the way it's mounted, or, and I've done this before, drilled out the little rivets and got me some small screws and repaired these. They're not that hard to take apart, but it's not working. And of course, shine up the coil cans. All the coils are good. The tubes test almost like new. I was really surprised. In fact, there was only one tube that was even the slightest weak, which was, and it wasn't weak by any means, but compared to the rest of them, excuse me, it was the detector tube, which is the same thing as First Audio. It's a 112A, and it read down just a few points lower than the rest of them. Otherwise, and it read plenty good. So, and let's see, this is the audio output transformer, checks good. Field winding checks good. So we're in good shape as far as anything else, except for this guy, which we'll get that figured out. One of the guys who subscribed to me has another chassis, a parts chassis, and Art, and we've been communicating. You can see him in the comments. He's going to check it out and see if the audio transformer's on it's good, and I'm welcome to him. So I really appreciate it, but there's not a super hurry. It's going to take a little time to get to this. Plus, for some, I've had some more comments about the sweep generators and stuff. So I'm planning on doing a video on alignment and using 4 different techniques, or basically 4 different ways. We'll be comparing notes between this style sweep generator, the pulse marker that I showed you in the last video, but showing how it's hooking it up and showing you what we get a reading on an actual radio. And then we'll disconnect it, we'll hook this one up, and I'll show you how to couple in this one to get a marker. And the difference between the 2 markers is the main difference. And then we'll do a video on VTVM. Mainly, I mean, as far as the IFs, you just basically bring the needle up as high as possible. Same way as with these, where you're just looking at the curve, trying to get the curve to the maximum amount. Here you'll just be getting the needle up as high. The main thing I want to do with this is show you how it works with a FM radio, and the discriminator, the S curve, and how you read that on here. And then alignment by ear, primary AM. You really don't, the S curve, the discriminator adjustment by ear is a really not good idea to try. You really need either a VTVM or a sweep generator is even better yet. But even with this, you can get a good alignment. But on AM, you can do by ear, and so we'll do something with that too. It may be a 2-part series, and then we'll get back to this. And I may kind of, if I'm getting to the point where I've got to figure out something with this or whatever, and I haven't yet, then we'll go to doing this guy. And this is that RCA 6K 6T/6T radio. So, and we'll get it all done up and stuff. So that's where we're at. And thanks for all your comments. And I got some new subscribers. Appreciate it. Hopefully we're going to be able to keep everything interesting and stuff. This is going to be kind of a fun project, and radio's actually in good shape. And these little guys down here, I tested them, and they tested beautiful. So, and the wire wounds that's in there are in good shape, and all the other coils. So these capacitors were definitely leaky as all get out. Most of them supposed to be 400 volt. There's only a set of 2 of them that's 150 volts. None of them using this here I could get above 50 volts. They just leaked like crazy. So they were really bad. So anyway, that's where we're at. So the next video we'll be dealing with the test equipment and the alignment on a radio. We'll just, if nothing else, we'll throw it out of line and realign it. So that's where we're at. So thanks for watching, guys, and thanks for your comments and all your support. I really appreciate it, and I honestly feel I got the best viewers on YouTube, to be quite honest with you. So you guys are all great. You're great friends. I appreciate it. So until next time, you have a good night, and I'll see you on the next video. Thank you.